Okay,
This
fine.
conference
So
will
please
now
make
be
sure you are
recorded.
being communicative in the class. You are getting your doubts clarified, and please be interacting. So this, trust me, it's a very good, interesting module, and you can get every topic only when you are paying attention. So don't attend the session for the sake of attendance. If you are doing such things, you please make sure you are being attentive in the class. And your attendance can be given anytime, so I can give you a QR anytime in between of the class, or somewhere at the end, or somewhere in the beginning itself. So, and once the QR expires, you cannot ask for any attendance later, and I cannot provide or mark the attendance later. So you please make sure you are marking your attendance when the QR is being provided. Uh, you don't have to buy. Okay, there's a question. We have to buy any hardware components to practice physically. That is not really required. So whatever hardware we had to work with, we are using a simulator, a software version of the hardware. So this software will work exactly as the hardware works. In fact, it works even more precise than that of a hardware. So we don't suggest you to buy any physical hardware components for the functionalities to be experienced. You can go with the simulation tool itself. But if you still want to buy, I can give you a link. It costs you around 4K, 3 to 4K for the board itself to be brought, and you need another like a dumper. So for your code to be dumped into your microcontroller, you need an intermediate device in between that additionally costs you around 2 to 3K. So I would say the overall cost of the hardware to be brought for this module costs you around 7K, which I wouldn't suggest just for the sake of practice. I don't think you may need it. But if you are very interested and you want to buy it, you can go for it. Ma'am, it will be in depth like advanced C. Yes, so everything is in detail. So you will see yourself. So as you had advanced C in depth, this will also be in depth. And yes, you are going to see the protocols also. Okay, fine. So let us initially start with what and all are we going to cover in this module. So these are the 4 chapters the complete module is being divided into. First one is introduction to the embedded systems, the very basic introduction of what exactly is an embedded system and what and all to be considered while designing an embedded system. Then what are the components of embedded system? So we are going to look the very basic things of embedded systems in a theoretical manner, and what and all to be taken care of while having an embedded systems design. So at the end, what we are concentrating is to have an embedded system design. So we will see its introduction first. And after that, we are going to start with introduction to the microcontrollers. So we are going to program a microcontroller. So we have to know what exactly is a microcontroller and how is that actually working, and what is the different options you have got while choosing a microcontroller. So that kind of basics are taken care of in introduction to the microcontrollers. Now, after that, we are going to start with embedded programming. So, I would say this is the chapter where we spend our 80% of the time. Okay. So, I can say approximately 12 to 13 classes we are going to spend here for understanding. I would say 12 to 15 in short. Okay. Or in 80%. Okay. Around 20 classes you think easily. So around 15 to 20 classes I can take to have the embedded programming considered. So this introduction to embedded systems may take hardly 2 classes, and introduction to microcontrollers will take 1 class. Okay. So this will be around 20 classes. You can count 20 overall. And this communication protocols will be around 7 to 8 classes. Okay. This 12 is wrong. This 12 cannot happen. Okay. So understand that this complete module, as I said, has around 28 to 30 working classes occupied. So first initial 2 to 3 classes we will go with introduction to the embedded systems and the microcontrollers. Embedded programming is where we actually program different peripherals, we interface different peripherals, we see the functionalities, how they are working, when are we going to use that peripheral in detail, we will understand. And each peripheral will have one or two programs. So we are going to learn the programming part also. So as I said, embedded programming will consume around 20 working classes. Then you will have communication protocols. So we are going to learn 4 different communication protocols in this module. So to list them, we have UART, SPI, I2C, and CAN protocols. Two of them have the programming part, two of them doesn't have a programming part, it is a theoretical part. But overall you will get an idea of 4 different protocols by the end of this module, which will consume around 7 to 8 working classes. So this is how the complete module is been split into 4 individual chapters, and every chapter is important. Each class will have continuity. So let's say one day I can speak about the theoretical part of a peripheral, the next day I might take with the programming of that peripheral. Okay, so that way things will have continuity from one class to another. And if you are by chance missing any class, you please make sure you are watching the recorded session. So this is how the complete module has been splitted, and apart from this, you have around 30 assignments to be done. Not all 30 are mandatory. So you have got some good number of assignments to be done and a project at the end. Apart from that, you have got a test to be taken. Okay. So that is about how the module has been individually split into the chapters. Any doubt in this? Okay. So please let me know if you have got any doubts anytime so that I'm getting it clarified. Now let us start with the very first chapter, which is nothing but introduction to the embedded systems. And okay, project, yes, we do have project also. So at the end we have one project to be done, which will be having every topic being discussed in the class. Course time duration for MC, as I said, it takes around 30 working classes. Okay. Now let us begin with the very first chapter, which is nothing but introduction to the embedded system. Okay. Notes for MC, there is no specific notes being created for the MC module as such. So whatever is required, I'll make a note actually. So I'll make use of notepad. So whatever is required, I will have it noted here, and I can share this document at the end of the module. So there is no notes being created as such. And whatever materials, let's say you need data sheet, you need schematic, so anything which is required is made available in your Moodle. Okay, so you will have Moodle provided. So I'm not sure if the course has been created yet. So once the course gets created, all the required documents will be added. Okay, so okay. So once the course gets created, you will have all the required documents available to you, and you can go through that documents created but not uploaded. Okay. So I'll check with it. Okay. So you will have all the documents made available. So every data sheet, every template codes. So everything will be made available to you, and you can actually go through that. So you don't, I don't have to literally send any documents anytime. So you will be made available with it. Okay. So I don't have access to this batch yet. So I think that has to be added. So anyways, let us not concentrate on that. As I said, after the proper course gets created, so you will have the documents provided. So for today, you can just manage with the slides I'm going to show in the class. Okay. Now let us start with, so the very first chapter we have got to start is nothing but an introduction to the embedded system. Can you tell me what is an embedded system? What do you mean by an embedded system? Please make sure you are being responsive. A combination of hardware and software. Okay. So everybody is saying a combination of hardware and software. Okay. So any other different answers? Hardware plus software, a combination of hardware plus software specified for a single task. Okay. Combination of hardware and software to perform a specific task. Fine. Any other answers? What exactly is an embedded system? Is it just a combination of hardware and software? Dedicated model of a controller. Okay. A microcontroller based system. Fine. Okay. Now, please understand, whenever you are asked to define what is an embedded system, you have to make sure there are three terms added for short. Okay. So basically, a system which contains a microcontroller or a microprocessor to perform a specific task. Okay. A microcontroller based system which is designed to perform a specific task. Okay. Now, as I'm saying, when you are asked to define or give a definition of embedded system, you have to make sure three things are being involved. One is a hardware, okay. Then second one is a software. So, embedded system is always a combination of hardware and software. Not just that, just a combination of hardware and software is not considered to be an embedded system. The most important terminology is specific task. Okay, so a combination of hardware and software which is performing a specific task is considered to be an embedded system. Okay, so whenever you are asked to define an embedded system, you have to make sure the three terminologies are included. One is hardware, second one is software, third one is a specific task. So a combination of hardware and software performing a specific task is nothing but embedded systems. So we are about to start with the introduction to the embedded systems. Now let us see what and all contents we have got to be studying here. First, the foremost thing is the introduction to the embedded system. Second, we have got to know the difference between the general purpose system and the embedded system. The third we have got to know is real-time aspects of embedded system. Okay. So first we will see introduction of embedded systems, general purpose system versus the embedded system. Then real-time aspects. Even though we don't design any real-time embedded system, we should know a basic thing regarding it. So we have real-time aspects of embedded system also. So coming to the introduction to the embedded systems chapter, we have got these many things to be discussing about. So first is what is an embedded system. Second one is the examples of embedded system. Third is a category of embedded system. Then we have components of embedded system. The requirements to be considered while having an embedded system design. The challenges you may face while having an embedded system design. The trends in development, what and all options you are provided with, and common design matrices of the embedded system. Now we just looked into the definition of embedded system, which is being put together here in the slide also. So any combination of hardware and software which is intended to do a specific task can be considered as an embedded system. Now we will try designing an embedded system. Okay, so a high-end embedded system. We are trying to design a high-end embedded system. Now assume you are asked to design an automatic, okay, you are asked to design an automatic gate opening system. Okay, so this is what you are asked to design. So you are asked to design an automatic gate opening system. Once can you open the last slide? Okay, is this the one you are asking for, Vinita? Okay. So a combination of hardware and software which is intended to do a specific task is embedded systems. This one. Don't worry, we will go with each and every point here. So I will revisit this slide again and again. So we are at the very first question, which is nothing but what is an embedded system? We are trying to find out the solution to that. So we defined that the embedded system is a combination of hardware and software doing a specific task. Now we are asked to design an automatic gate opening system. Now please understand I am trying to design a high-end automatic gate opening system which is purely hardware based. Okay, so this is purely hardware based. Now tell me, to have an automatic gate opening system which is purely hardware based, which is the very first component I need? Which is the very first component I need? A gate. Okay. Now before a gate, yes, I might need a sensor. So I will choose a sensor. Okay. There are different types of sensors. There are IR sensors, UV ray sensors. There is PIR sensor. So there are different kinds of sensors. Let me just keep it as sensors now. Okay. So the very first and the foremost important component I'm taking is a sensor. Now, second one, what do you think after sensors? What else do you need? What else do you need? Okay, you will say a microcontroller or a microprocessor. Now, I actually can take a microcontroller or a microprocessor. That is fine to take. But the problem is I'm trying to design a purely hardware based system. To configure this microcontroller, I may have to need a software also. Do you agree? So to program this microcontroller, I need a software. Now, because I want to design a high-end purely hardware-based system, I'm going to ignore the microcontroller. Okay. So first component I'm keeping is sensor, which is used to sense the signal. Now, after the sensor senses the signal, what should be done if there is a human appearing near the gate? What should be done with respect to the gate? Should it be opened or it should be closed? I have to open the gate. Okay. So I need a gate. Okay. I'm going to need a gate. But to open the gate and close the gate, I might need a component which is nothing but a motor, isn't it? So to open the gate and close the gate, I want a motor. Now coming to the motors also, there are n number of motors. There is a AC motor, there is a DC motor, there is a stepper motor. So they have got multiple types of motors. So I am not going to concentrate on motors. Instead, I'm going to concentrate on their driver circuit, which is nothing but the relay. Okay, so I'm going to take a relay here instead of the motor. So what happens here is there is a sensor which is sensing the signal. According to the signal, so I have to instruct the relay whether to turn on the motor and open the gate. Now, if any output device you are going to consider will be called as actuators. Okay, so let's say any output device you are going to take, they are technically referred as actuators, and in our case it's the gate which needs to be opened. Okay, Now what happens is sensor is going to sense the signal. Do you think for any value the sensor gives, you're going to open the gate? Will you open the gate for any value the sensor gives? No. So after sensor gives you some value, it will be compared with some threshold value. So I will have a threshold value kept, threshold value, or you can say a predefined initial value. So depending on that, if the sensor gives a value equivalent to the threshold value, only then I have to open the gate. Else I shouldn't be opening the gate. Now, what do you think I need to check if the sensor is giving me a value uh, which is related to the threshold value? So, what do I need in order to check whatever sensor is giving? It gives you a signal. So, that signal has to be checked with the threshold value. Only if it reaches the threshold value, I have to open the gate. Else, I don't have to open the gate. So to do that, I need a component called comparator. Yes. Okay. So I need a component called comparator. So please ignore the mistakes in the spellings. So I'm taking a comparator. Okay. So now what happens is sensor is going to sense the signal. It compares with a predefined threshold value with the help of a comparator. Now, if the value is greater than or equal to threshold, then it instructs the relay to turn on the motor. So, motor will in turn open the gate. Now, once the gate is opened, will you keep it opened permanently? Once the gate is open, will you keep it open permanently? No. After some duration, you are going to close the gate also. Now, what do you think you need to close the gate after some time? Yes. So, I need something called as the timer. Okay. So, I need a timer. Now, see how this is working. So, assume there is a sensor. Okay. So, sensor is going to sense the signal, which is in front of the gate right now. Sensor senses and gives you a signal. That signal will be compared with the threshold value with the help of a comparator. After comparator compares the value with the threshold value, if the value is a match, it is going to tell the relay to turn on the motor. So motor in fact is helping the gate to be opened. Then timer is running for certain amount of time. So after let's say 2 minutes, so this timer will again instruct the relay to turn off the pump. Okay. I mean to turn off the motor. In that case, the gate is going to be closed. Okay. So you can either turn off, or if you want, you can run the motor in a different direction. Okay. To have the gate closed. So it is completely up to you how you are controlling it. Okay. So I'm just giving you a simple example. Sensor is sensing the signal, compares it with the comparator. If it is greater than or equal to threshold, relay is set to move the motor in such a way that gate is opened. So after some amount of time, it is going to tell the relay to run the motor, in fact, which is used to close the gate. So this is the basic working of an automatic gate opening system. Now think and tell me, with all of these components, will I be able to design an automatic gate opening system? Do you think all of these components will help me work as an automatic gate opening system? No. Why do you think it is a no? Why do you think this will not have me an automatic gate opening system design? Okay. So, yes, electricity, consider you are giving the power also. Okay. So, assume you are giving the power also. So, please understand with these hardwares, yes, it may be possible for us to design an automatic gate opening system. If not very precisely, So I will still be able to manage designing an automatic gate opening system. Now, the reason why I took this example is this is a purely hardware based system which is performing a specific task. Will you consider this as an embedded system? So this is a purely hardware based device, okay, which is performing some specific task, but you don't call it as a embedded system. The reason is there is no software, correct? So a embedded system should have both hardware and software which is performing a specific task. Okay, so what happens is sometimes you will have a system which is purely hardware based performing a specific task. Sometimes you will have the system which is purely software based also doing a specific task, but they cannot be considered as an embedded system. So an embedded system should always be a combination of hardware and software, and especially it should be doing a specific task. So that is nothing but an embedded system. Can you now give some of the examples of embedded system? So examples of embedded system which you have been going through every day. A computer is an embedded system. I never knew this. Okay. A washing machine. Yes, I can consider a washing machine as an embedded system. Then LCD TV. Okay, I will take smart TVs. So that can also be considered as an embedded system. So then mobile phones, it is interesting. So if you go with mobile phones, okay, escalators, your ATM machines, your printers, they all can be considered as embedded systems. But do you think mobile phone is an embedded system? Will you consider mobile phone as an embedded system? So because I'm being very specific to my definition, it has to be hardware, it has to be software doing a specific task. If you take a mobile phone, it is having hardware, it is having software inside it. But do you think mobile phone performs a specific task? Will it perform only one specific task? No. So it is going to perform multiple things, even more what you cannot do in your laptops. So it performs multiple things. So in fact, mobile phones are not an embedded system according to the definitions we have made. Okay. But if you look at the list of the examples on our slide here, okay. So to start with, let me tell what and all these things are representing. So first and the foremost thing is radio player and embedded system. Uh, Actually, just a radio player cannot be considered if the software is not involved. So if you're like just broadcasting and just listening to it, that will not be if the software is not involved. But obviously, to collect the signals, you need a software written, so you can consider it to be an embedded system also. Okay, fine. So here are the list of the examples of the embedded system. The very first one here, you can call it as a microwave oven, or you can consider it as a digital lock. Okay, so that is the very first example. Second one is a washing machine, a fully automatic washing machine. Then you can see a smart TV. Then you have a camera. Then you have refrigerator. So this is home appliances. So this one is you can consider it as an automatic car or a driverless car. So this is an example of a robot. This is an example of avionic applications. So this is the example for medical applications, the MRI. This you can consider it as a hard disk or a floppy disk. So this you can say it as a router of your Wi-Fi. What is this? What is this here you're seeing? It's a rover. Yes. So that's a rover. Okay. So not specific. Chandrayaan 3. No. So that was not the picture we made when Chandrayaan 3 got successfully launched. That's a rover. Okay. The very first one we used. So that's the rover. So this is an application for missile field. So it's a missile. And here I just said that mobile phones are not a part of embedded systems. But you still can see mobile phones being put under the examples of embedded systems. We have a reason for it. So in fact, mobile phones are not 100% embedded systems. We still consider it to be an embedded system for a reason. So we will revisit this point when we go with the difference between the general purpose system and the embedded system. So when we talk about the difference between the two, we will consider why mobile phones are put under the examples of embedded systems. So remember this point, we are going to revisit it later. Automatic fire alarms, okay, ADAS, okay, railway tracks. Railway tracks, uh, the tracks are not of the embedded systems, but see, earlier the trains were running with just the charcoal or diesel or petrols. So if that was the case, then railway tracks cannot be considered as an embedded system. But these days they run with electricity, they run with a program being written to it. So we have the mechanisms of finding out the traffic of the rails with a signal being sent. There will be a link connected at the top of the train. So that way we have, yes, we have a mechanism of tracking it. So that can now be considered as an embedded system. Drone, yes, it is an embedded system. ATM is also an embedded system. Railway GPS tracking, that is an embedded system for sure. Okay. So traffic lights, these days, okay, when you are considering timers and all, switching between the lights, so you can consider it as an embedded system. Escalator, yes, it is. Can be called relay switch as an embedded system? No. So just a switch, a relay switch cannot be considered as an embedded system. A fitness tracker, I would say a smartwatch these days. So that is, yes, an embedded system. Okay. So Alexa, yes, that is also an embedded system. Traffic signal is also an embedded system. Yes. So these are the examples of an embedded system. And as I said, this mobile phone is in fact not an embedded system exactly, but still we have put it under embedded systems. We are going to revisit this topic going ahead. Any doubts with this? Okay. All right. So let us proceed with the next thing. Okay. So the next thing we have got to discuss is nothing but the categories of embedded system. So let me take you to the next slide. So categories of embedded system, if you think, there are majorly 4 categories of embedded system. I'm going to note it down here. So we are talking about categories of embedded system. So we majorly have 4 different categories of embedded system. First one is a standalone embedded system. Okay. Second one is a real-time embedded system. Then we have networked embedded system. And the last we have got is mobile embedded system. Okay. So standalone embedded system has been further divided into independent. Okay. First is slave standalone embedded system. Then we have independent standalone embedded system. Will you share this PDF? No, Mahesh. I cannot share this PDF because this PDF is in fact having everything in detail from the beginning to like not in detail. We have just got the brief points added. But the problem with this is it has every topic to be covered at once, and there might be chances that you may go through the other topics ahead of what we are teaching right now, and you may ask doubts on it, or you may not understand everything being put in the slide. So nothing is like 100% informative in the slide. We have just put some important points on the slide. So referring a slide is not easy or something I would prefer. So you will not be provided with the PDF right now. So at the end of the module, we can get it added. Recording session will be there for today's class, ma'am. Yes. So recording will be available for every class. I have started recording. So once the class gets over, in the next 30 minutes, I will be able to get the link. And once the link gets created, I will be uploading it in your Moodle. What about this notes which I'm writing right now? So I will be providing you at the end of the module. Okay, fine. Let us continue. So we were discussing things with respect to the categories of embedded system. The first one is slave standalone embedded system. So an embedded system is considered to be a slave standalone embedded system when it doesn't have any intellectual part associated to it. Okay, so you will not have any intellectual part. They don't have the mechanism of deciding what to take action and when to take action. They just blindly follow every instruction you are going to provide. Okay, so they are slave standalone embedded systems. So they follow every instruction being provided by the user. So an example of a slave standalone embedded system, I would say, is an very old semi-automatic washing machine. Okay, so I will say semi-automatic washing machine. Have you observed in your semi-automatic washing machines, the one which we were getting it earlier? Okay. So what happens here in the semi-automatic standalone? It's like a name being provided. Okay. So it is an independent type of an embedded system. Okay, so it is just an adjective which has been provided, so nothing specific. So means it is also performing a specific task for sure because it is an embedded system. So standalone means which it can do on its own, an embedded system which can take action. Okay, so that is just a standalone. So the very first basic category was a standalone embedded system itself. It is further divided into slave standalone and independent standalone. Okay. So slave standalone embedded systems example is a semi-automatic washing machine. If you remember earlier when we had a semi-automatic washing machine, do you remember that we had to put clothes by ourselves? We had to put detergent by ourselves. We had to fill the water to certain level by ourselves. So that was also there. So everything was literally had to be fed by the user, and when the switch had to be turned on, the motor was running for certain amount of time. Now why I say they don't have an intellectual part is, if you can correlate, assume you have bought a semi automatic washing machine, you put clothes, you put detergent, but you forgot to put water. Okay, it forgot to put water. So even without putting water, if you turn on the washing machine, was it working or not without water? Yes, motor will still run, isn't it? So its task was just to run a motor for certain duration. It didn't have an intellectual part to make decisions on its own. Okay, but that is not the case when it comes to the fully automatic washing machine, which is an example of independent standalone embedded system. A fully automatic washing machine, if you say, that is a good example of an independent standalone, because in these days, whatever washing machines we get, so we don't control inlet, we don't control outlet, and even if the water is not there, okay, if the water flow is not sufficient, it gives you an error, isn't it? Will it still run in these machines if the water is not there? It will give you an error, isn't it? It won't run. It shows you an error on the display. So that is because it has an intellectual part which can make decisions on its own. Yes. So even if you try opening the door, now the door comes with a child lock facility. So if you try opening the door, obviously it won't. But if you still open the door, the motor is not going to work. Okay, because it has an intellectual part. It can take decision on its own. So that is an example of independent standalone embedded system. So one more example of slave standalone embedded system is your microwave oven. So what happens in the oven? The reason why we buy an oven is to heat the food. Okay. So that's the only reason we buy an oven, to heat the food. Now let's say you buy an oven, you turn it on, and you forgot to place the food. You have just turned on the oven. You forgot to place the food. Will it turn on or not? Will the oven run or not? It obviously runs. Even though food is not there, okay? So even though food is not there, your oven will still run, okay? So because it doesn't have an intellectual part, whatever you say will be blindly followed. So that is slave standalone embedded system. But in case of independent standalone embedded system, they will have an intellectual part which can take the actions or which can make the decisions on their own. So one more example of independent standalone embedded system is a driverless car. Okay, so I would say an automatic car. Okay, so that is also an example of an independent standalone embedded system. Now, have you heard of Tesla or Google car? Have you heard of it? Yes. Now it's a driverless car. So car is running on its own. Now assume there is an interruption. Somebody comes in front of your car. Will the brake be applied or not? So will the brake gets applied? Yes, it has to. So that is because it has an intellectual part which can make decision on its own. Depending on the scenario, so it can make the decision on its own. So that is standalone embedded system, a slave standalone embedded system and an independent standalone embedded system. So slave standalone embedded system will not have any intellectual part, but independent standalone embedded system will have an intellectual part associated to it. Apart from that, we have something called as real-time embedded systems also. So what do you think real-time embedded systems are meant to do? DVD drivers, they are, I would say, slave. Autopilot is independent. Okay, are you telling for real-time embedded system? Okay, Ajinkya is saying it stops after, but anyways, after few minutes it stops. Okay, but if you put it on, it still runs, no? So it is turning off these days. Earlier, actually, what was happening in the DVD drivers we had was, if it is not there, if you have not put, by default the driver is coming out, it would pop out actually. Okay, so that was happening. That was because it was a part of an embedded system, or maybe it had a sensor which used to sense this, but not exactly independent standalone. So it couldn't take the action immediately depending on the situation it is working. So I would say it is still a slave standalone. And with this mic is on. Are you able to see the mic, Rajbar? Okay, can you hear me now? Okay, fine. So I was asking for examples of real-time embedded systems. Okay, so real-time embedded systems are the one which are supposed to take the action on time. So any real-time embedded system was meant to take the action on time, which gives the output in a specified time. Exactly. So a real-time embedded system should always make sure to take the action in the specified amount of time. So it has to take the action in the given time, else it might harm the device or it might harm the human life. So real-time embedded systems are meant to take the action on time. So the examples of real-time embedded systems are, so yes, I can say fire alarm, okay, or you can say brake appliance system, the brake system, okay. Apart from that, I can say airbag system, okay. So apart from that, live streaming, yes, so that is also there. But the problem with live streaming is, yes, it has to make sure it is happening on time, else it is going to make some issues. Then I can say robots, okay, or GPS trackers, yes, the airbag systems, yes. So all of them are meant to take the action in the given time. If not, they are going to risk the human life or cause damage to the devices. So they are real-time embedded systems. Okay. Then networked embedded systems. MRI. Uh, okay. So not a real time. They are. I can say real time because if a human is sent it, it has to scan it in the given time. Okay. So real-time embedded systems are further categorized. We will see it later. But okay, MRI can also be considered as a real-time embedded system. Then coming to networked embedded system, networked really means the things being connected. Okay, so either with wired or wireless connection doesn't matter. So networked means things being connected. So when it comes to the networked embedded system, CAN is just a protocol. Okay, a protocol which helps you communicate between two devices. Okay, so networked embedded systems means the things where the components are connected one to another. Just a router, okay, you will have mobile phones connected, but if you take apart from routers, yes, the CCTV systems, or I can say home automation, okay, where all of the devices will be connected to one another. So home automation, or you can say your ATM machines where one will be connected to another. Satellite, okay, home automation is like you're including everything, your Bluetooth, your IoT devices, where devices are connected one to another. It's a networked embedded system. And what do you mean by mobile? What do you mean by mobile here? What do you think mobile embedded system means? Yes, so mobile means which is capable of moving. So any embedded system which is capable of move or which can move are called as mobile embedded systems. You can consider some robots. You can make Google car. Okay. So your smartwatches are not mobile. So they cannot move on their own literally. So they move only because you are wearing it and moving. Okay. So the ones which are movable by themselves. So they are mobile embedded systems. Example, robots and Google car. Now, apart from these, yes, drones are also good examples of mobile embedded systems. Now, apart from these four, we also have something called as hybrid embedded system. That is because some of the embedded system may belong to more than one of these categories. A good example is a Google car. Okay, so if any particular embedded system falls under more than one category here, you can consider it as a hybrid embedded system. And best example is Google car. So Google car belongs to independent standalone embedded system. It can make actions on its own. It belongs to real-time embedded system also because it has the brake system, it has the airbag system and all. Then it belongs to networked embedded system also because all the components in the Google car are connected one to another. Then it belongs to mobile embedded system also because it is capable of getting moved. So if any embedded system belongs to more than one category, then you can put it under hybrid embedded system. The digital cameras, I would say, is like a slave standalone embedded system. Vacuum cleaners are like, okay, you can go with movable mobile embedded system. Electric bikes are mobile embedded systems. So DVD players are like slave standalone embedded systems. So if a embedded system belongs to more than one category, then you can consider it as a hybrid embedded system. Yes, electric bikes we can consider it as hybrid also because things are connected, so network is playing a role. Then real time embedded system, if you see, it manages the battery life and all, so you can put it under real time embedded system. Yes, you have a display. Just because display, you cannot put it under a particular category, so it is not something which gets considered while you are differentiating. A stepper motor, individual component generally will not have anything. A motor is like it is working with the electric supply you provide. So there is no embedded things involved there. Ola electric bikes hybrid, yes, I said you can go for put it under hybrid. And these are the categories of the embedded systems: standalone embedded system, real-time embedded system, networked embedded system, mobile embedded system, and hybrid embedded system. But it works on the time control. Okay, that is only because you have connected it to a timer. You are programming that stepper motor. Okay, so you are the one who's programming it. So you have got a timer, you have written a program, you are making the motor run for certain times, close the, like not to run the motor. So it is you who's controlling it. So it is just a device. A bulb, if you take, it is just a device. Okay, so using that, you can have an embedded system design. Okay, so these are the categories of embedded system. The next we have got is to, sorry, the next we have got is to start with the components. So let us take a break of 2 minutes and then continue. Okay, can we continue? Uh, and what about telematics? What is telematics as such? I have no idea what telematics is. Can you brief out? Like, I haven't heard of it. Mm, tracking devices. Okay. So, long distance transmission of computerized information is telematics. Okay. So, yes, that is a networked embedded system. Then tracking devices, so if they are connected to each other, it belongs to a networked embedded system. Okay. So it is like collecting data from the vehicles. Okay, fine. So it is networked. Okay, because things are connected to each other. It is networked embedded system. Okay. So that is it about the categories of embedded system. Now let us move to the next topic, which is nothing but the components of embedded system. Now here is a list of the components of embedded system we are going to study. And the very first and the foremost important component is the microcontroller or microprocessor or SoC. So this is the first and the foremost important component. Okay. So I can understand microcontroller being a part of the embedded system, but you have never heard of, I think you have never heard of something called as the SoC. Is there anybody who knows what SoC is? Anybody there who knows what an SoC is? Source of code? No. Yes, so SoC here stands for System on Chip. Okay, so SoC here stands for, yes, System on Chip. Now, so this is considered to be the most important component. So the very first important component is either your microcontroller or microprocessor or system on chip. Now system on chip is just nothing but you having multiple microcontrollers or multiple microprocessors on a same chip. Okay, so you are going to have multiple microcontrollers or microprocessors in a single chip. So that is called a system on chip. Now the question comes is, why do you need a system on chip when you already have a microcontroller or a microprocessor? Or the question says is, why do you need multiple microcontrollers or multiple microprocessors? Now let us take a simple example. So now this was something we considered as an example of a embedded system. Now because it did not involve a microcontroller or a microprocessor, and the software was not considered, we did not consider it to be an example of an embedded system. Now if I add a microcontroller or a microprocessor to this example, will you consider it as an embedded system? So if I add a microcontroller or a microprocessor to this, will you consider it as an embedded system? Okay, yes. Because it involves the software along with it, you can call it as an embedded system. Now, so I would consider that as the very first important component. Okay, this is the second component. So this will be a microcontroller. Okay. Now assume this automatic gate opening system is being designed for a mall's entry. Okay. So you are going to design it for a mall's entry, or I can say a hospital's entry. Okay. Now, is there any differentiation made for the people who enter to the mall or a hospital? Is there any differentiation you are going to make for the people who enter a mall or a hospital? No, right? So anybody who enters the mall, the gate has to be open, or anybody who enters the hospital. So like just consider a door or the opening the glass door what you have in your malls or big hospitals. So that is what I'm talking about. So they literally don't have any differentiations made. Okay. So for anybody who's in front of the door, so the door has to be open. So for the mall and the hospital, if you see, are let's say the entrance of a metro station. So something like that, where differentiation is not literally considered. So there the work is simple. You can just work with a single microcontroller or a microprocessor. But assume the same is being designed for, okay, uh, let's say this is being designed for a jewelry manufacturing company. Okay, so jewelry manufacturing company. So I'm not talking about a showroom. Okay, so it's not the showroom. I'm talking about the jewelry manufacturing company. Banks is like, even in banks, anybody who's in front of the gate will be allowed inside. Okay, so I'm talking about the main gate. Okay, so I am trying to design a gate for a jewelry manufacturing company. Now tell me, do you think everybody who's in front of the gate will be allowed to enter? No, right? So not everybody will be allowed to enter the jewelry manufacturing company. Only owners and workers will be allowed to enter. Now even if you take the workers, okay, assume the workers of this manufacturing company are working in two different shifts. Okay, or in fact, they are working with three different shifts. So, one set of people are working from 8 a.m. to 4 p.m. Okay, another set of people are working from 4 p.m. to 8 p.m. Okay, or let's say 10 p.m. And another set of people are working from 10 p.m. to 8 a.m. Okay, there are three set of people working in the jewelry manufacturing company. Now let's say a person who is working in a slot of 4 p.m. to 10 p.m. tries entering the premises in 8 a.m. Okay. So a person who is working at 4 p.m. to 10 p.m. slot is trying to enter the premises at 8 a.m. Do you think he will be allowed to enter? Will he be allowed to enter? Obviously, no. Now, how do you make the differentiation here? How will you not allow a person from 4 p.m. shift to enter at 8 p.m.? So you have to give the access. You will give identity cards, okay? You may give the barcodes, you may take the biometric, and some of the cases you can take the face recognition, okay? So remember, there is a differentiation for you to make, okay? So here there is a differentiation for you to make. Apart from that, there is a security man, okay? So there is a security man who is working in two different shifts, okay? One security man works from 8 a.m. to 8 p.m. Another security man works from 8 p.m. to 8 a.m. Okay. Now, will you allow a security man working from 8 a.m. to 8 p.m. to enter the premises around 10 p.m.? Will you allow it? No, right? And there is a separate differentiation to be made. One more database. So here three different databases for three set of people. Here two different database for another two set of people. So who belongs to the security purpose. Apart from that, let's say there is an owner. Okay. So do you think you can stop the owner's entry at any point of time? Will you stop the owner's entry? No. Owner should be allowed to enter the premises at any point of time. Now see, there are multiple things you have to take care of. Okay. So you have to take three different slots of the working employees. Then you have to categorize security people. Then you have to categorize the owner. Then each of the category has different slots. Don't you think while implementing the system you have too much of functionalities to be taken care of? Don't you think there is too much of things you have to be considering? Yes. So that is when you cannot perform all of this with an individual microcontroller or a microprocessor. I wouldn't say cannot, I would say that it is quite difficult or challenging to have an embedded system designed with all of these functionalities using a single microcontroller or a microprocessor. So it is challenging, which is why you may have to need multiple microcontrollers or microprocessors. Now, having multiple microcontrollers or microprocessors, you have to like individually buy them, configure them, and you have to use it. Instead, you will have an option to choose the system on chip, which will have multiple microcontrollers or microprocessors already embedded. Okay. So whenever you need multiple functionalities to be involved to perform a specific task, here the specific task is just opening the gate. Okay. But for that, you have multiple functionalities to be taken care of. So whenever you have multiple functionalities to be taken care of to perform a single task, where you cannot handle it with a single microcontroller or a microprocessor, you will have to choose multiple microcontrollers or microprocessors, for which you go with an SoC. So SoC stands for System on Chip. So that is the very first component. Understood why do we need an SoC? Everybody, is this clear? Okay. Now, apart from this, what else do you think is another important component? Apart from microcontroller, microprocessor, or system on chip, what else do you need? Yes. The second important component here is the memory. Okay. So, the second important component here is the memory. So, after the first important component, this is memory. Okay. So your microcontroller or microprocessor or SoC, we call it as the heart of the embedded system. Okay. So that's the heart of the embedded system. but memory is considered to be the brain of your embedded system. So the second important component is the memory. Now this memory, you have different types. Have you known the types of memory? Yes, which are those? The very basic types of memory? Yes. So one is RAM, the other one is ROM. Okay. So RAM and ROM. So generally, ROM is considered to be the primary memory and RAM is considered to be the secondary memory. Or I can say ROM as non-volatile memory. Okay. And RAM as volatile memory. Okay. So ROM is a non-volatile memory and RAM is a volatile memory. So what do you think ROM stands for? What do you think ROM stands for? Yes. So that is read only memory. And RAM stands for? Okay. So it is random access memory. Have you known the types of ROM? Have you known the types of ROM? If yes, can you please list them? What are the types of ROMs available? Okay, one is EPROM, that is right. Okay, so the other one is PROM. So first type in fact is a PROM. Okay, second type is a EPROM, and double EPROM is not a type of ROM. Okay, so third one is something called as masked ROM. Okay, so these are the three types of the ROM. So one is PROM, then EPROM, then masked ROM. Now PROM stands for programmable ROM. Okay, so it is called as programmable ROM. Now what does this programmable means? Okay, so you can program this ROM, okay, before it is being after it is being manufactured. So you will be allowed to program this ROM. So you can have your data return at once to this ROM. But remember, you can write it for only once. Okay. So PROM is also called as OTP, which represents one time programmable. Okay. So one time programmable. So PROM means programmable ROM. So you can write into this ROM for only once after the ROM is being manufactured. So generally it comes with the data return. Okay, while it is being manufactured, it comes with the data return. So whatever is written inside the ROM is like a hard code, hardwired. You can just read. But OTP means one time programmable. Even after manufacturing it, you will be allowed to have the data return for only once. So we also call it as OTP. The very common place where this programmable ROM is used is in your toy industry. Okay, so toy industry is where you are going to make use of the PROM. Then we have EPROM, which is representing erasable programmable read only memory. Now I'm telling it is read only, but I'm also telling it is erasable programmable read only memory. Okay, I'm telling I can also erase the data. So what happens here is you can write the data and you can erase the data for any number of times. Okay, so you can erase the data also, you can rewrite the data. But the problem here is if you have to erase the data which is returned into this memory, you may have to need a UV rays. Okay, so you will need UV rays to erase the data which is returned in the EPROM. So EPROM is also referred as UV ROM because we are going to make use of UV rays to have the data erased. Now assume you have an EPROM in your device. You write the data to your device for once and you feel you want to rewrite the data. Do you think we humans will have UV rays along with us to have the data erased all the time? Will we have UV rays with us to have the data erased all the time? No. That is not easy for a human being to carry UV rays along with him to have the data erased whenever he wants to rewrite. Which is why this EPROM is generally used in case of, please understand, EPROMs are always used in R&D departments and research laboratories. Okay, so very commonly used in R&D departments. It is easy to get things in the R&D department when it comes to the UV rays. So EPROMs are generally preferred in R&D departments and in research labs. Okay, so that is EPROM. Then we have masked ROM, okay, where data is written only for once while the device is being manufactured. Okay, so while the device is manufactured itself, you will have the data written. You will not have any chance of writing the data again. So, what do you think by masked in general? What do you think masked means in general? We call it as masking. Yes, so that is something called as hidden. So you want to hide, you don't want to show the data, and you don't want others to modify that data. Okay, so we are not going to have our data modified. So that is masked ROM, like our new phone having hidden OS data. Okay, so masked ROM means you are going to have the data return while the device is being manufactured. So the place where this masked ROM is used is to have your bootloader. Okay, your bootloader is always written on a masked ROM. What do you mean by bootloader? What do you mean by a bootloader? Any idea about a bootloader? Yes, which loads the operating system, correct? A startup code, correct? So bootloader is nothing but a set of instruction which is used to load the operating system to your device. And this bootloader should never be harmed. Okay, so this bootloader should never be harmed. So I'm talking about the masked ROM, which is having a ROM where data is written while the device is being manufactured. So when the device is manufactured, you will have the data written. Okay, so you have the data written in such a way that first of all it is hidden and nobody should be able to reprogram it. Okay, so I am taking a masked ROM which is having a where a bootloader is written. So bootloader is a very important program which is used to load the operating system to your device. So if you damage bootloader at any point of time, it is not going to make the operating system work fine. So bootloader is always returned into a masked ROM. So we have three types of ROMs: the programmable ROM, which is one-time programmable only. Then we have EPROM, which is erasable programmable read-only memory. But to have the data erased, you need UV ray. So we also can call it as UV ROM. Then we have masked ROM, where a bootloader is written. Not just this, your audio CDs, which you get for your movies, and all. Earlier we used to get that, where the data cannot be modified at any cost. Okay, so they all are an example of masked ROM. So these are the types of the ROM. Clear with this? Okay, now coming to the RAM. Have you known the types of RAM? I have 115 participants and I see only 10 or 15 being responsive in the class. I don't know what others are busy with. Okay, So we have two types of ROM, which is also called as a volatile memory. So first type of ROM is something called as SRAM, and second type of RAM is called as DRAM. Okay. So SRAM stands for static random access memory, and DRAM stands for dynamic random access memory. Okay, as the name clearly says, it is random access, so you can access the data on a random basis. So that is random access memory, and it is said volatile because the data will remain in the memory only until the power supply is being provided. Okay, until the power supply is provided, the data remains in the memory. Once the power supply is not provided, the data in the memory will be lost. Okay, so this RAM is a type of a volatile memory where the data is lost once the power supply is not provided. Now we have the two types of RAM here. One is static RAM, the other one is dynamic RAM. So static RAM is the very basic type of the RAM where data is lost once the power is lost. So until the power is there, so data will be remaining in the device, and once the power is taken out, so data will be lost. Okay, so whatever cache memory you have got, they all will be stored in the that is a example of SRAM. So your cache memory, if you have heard of it, so that is a example of your SRAM. Okay, apart from that, in case of DRAM, so which stands for dynamic RAM, so here it is like a short-term memory loss. Okay, so DRAM is like a short-term memory loss. So I can say in case of DRAM, the if it is a capacitor-based DRAM, so there are different categories of DRAM also. Now, if you take a category of DRAM which is based on capacitor, while you charge the capacitor, the data will be there in the memory. While the capacitor is discharged, the data will be lost. Okay, so data will not be there. So what happens in the DRAM is the cells which are used to store the data has to be refreshed on a regular basis. So in case of DRAM, whatever data is stored in the memory has to be refreshed on a regular basis. So that is very necessary for the data to be refreshed whenever it is being used. So that is why we say between the SRAM and the DRAM, okay, so between the SRAM and the DRAM, so it is always the DRAM which uses more power compared to that of SRAM. So DRAM is going to use more power because the cells of the DRAM has to be refreshed on a regular basis. It consumes more power compared to that of the SRAM. So DRAM consumes more power compared to that of a SRAM. Okay, but apart from that, the main memory, so whatever RAM you say in the computers, the main memory is actually made up of DRAM. Okay, so DRAM is the one which is used in the computer's main memory. Okay, so if you generally talk about RAM, then you are talking about DRAM in your device. Yes, that is also volatile, as I'm saying. While the capacitor is being charged, data will be there. Capacitor is being discharged, data will be lost. So it's like a short-term memory loss. Have you heard of Gajini movie? Gajini movie? Yes. So what happens in the Gajini movie? What exactly happens to the lead cast in the movie? So the actor will be losing the memory for a short term. Have you observed? Yes, so there is short-term memory loss. So very similar to that in DRAM also. So it is going to experience a short-term memory loss. Okay, so it loses the memory for a short period only while the data is being discharged. So I mean while the capacitor is being discharged. So that is why we call it as the dynamic RAM. So it is also volatile as you lose the data when the power is removed. Okay. So these are the two types of the RAM. While playing games, it uses DRAM, not just playing games. So for every process which is running in your device, for every application which is running in your device, it is going to use some memory, and that memory is always from the DRAM. For any process to be running, it needs memory for sure, and the memory will be occupied from the DRAM only all the time. Okay, so if half power of capacitor is discharged, half data will be lost. No, so all the data will be taken care at once. So there will be threshold which has to be maintained. Okay, so not like half data is lost, or if it is lost, it's a complete data. If it is there, there is complete data. Okay, so that is the second type of RAM, which is nothing but the DRAM. Now the problem comes is, like we play movie, it works on DRAM as to load part of the data to be displayed and refreshed to display the next scene. Okay, you can say that. Are they separate RAM cards, ma'am? Yes, there is either there is SRAM, there is DRAM. So there is two types of RAM available. So your cache memory is using the SRAM and your main memory is your DRAM. Then DRAM should have more storage capacity than that of the SRAM. So capacity is not a matter of concern here. So even SRAM can have the same capacity as that of a DRAM. You are talking about the functionalities of it. Okay. So in our case, we take cache memory. In most of our devices, we will have very less dedicated space for the cache memory. That is because we don't use it cache memory is not something which is regularly used. Okay, so you will have only temporary files, some plugins, some unwanted temporary files being stored. So that is why cache memory is provided with less memory. Main memory will have more, but that doesn't mean it has more capacity. Even you can choose to take SRAM of a bigger size also. Okay, so we are just knowing the functionalities. So capacity here are the same. So that temporary memory, can we make part of it permanent? No, so any data being stored in SRAM and DRAM are temporary only. So that is why it's called as a volatile memory. If you want them to be stored permanently, you have to make use of any of the ROMs. Okay. Now, actually, if you go with any embedded systems design, or if we go with a real life scenario, we cannot be working with an individual ROM, or we cannot work with the RAM alone. Okay. So both of them have their own disadvantages. Now assume I buy a mobile phone. Okay. Assume I buy a mobile phone. So, or a girl. Okay. So she is going to buy a mobile phone. What do you think is the major reason for a girl to buy a mobile phone? Very first thing. So why do we buy a mobile phone? For pictures or photos. Okay. So obviously it is for the pictures. Communication is like the least thing we consider. Communication can be done on any other devices. The very first thing we look is with the camera quality, the storage, how much it can store, things that way. Okay, now let us take a simple scenario. Nibin is laughing. Okay, so for sure, yes, for the selfies. Okay, now assume I take a picture. Okay, so I take a picture. In my mobile phone, assume the memory available is PROM. Okay, so I take a picture. My mobile phone's memory is PROM. Now I take a picture. I will store it into the PROM. Okay. Now, do you think we girls stop at taking a single selfie? Will we stop after taking a single selfie? Obviously, no. So, I feel the selfie I have taken is not good. I want to retake the selfie. Now, if I want to retake the selfie, do you think my PROM allows me to write that selfie again into the memory? No, it is one time programmable. I can take only one selfie, get it stored. Having another selfie taken is not possible because I cannot store it in the OTP. I mean, the PROM. If you have an EPROM, to have it erased, I need a UV rays, and I will not carry UV rays along with me. So that is also a problem. And mass ROM, I don't even have a choice of writing it into it. So I cannot have a mass ROM. So none of the ROMs are suiting my application. Now let me take a RAM. So it is random access memory. Do you agree that I can store the data of any amount? So do you agree? Like I take a selfie, I feel it is not good. I take one more selfie. So I take one more selfie. I take hundreds of selfies. I can store it inside the SRAM or the DRAM, right? So capacity can be selected. Rewriting the data into the memory is possible. So once I write the data, if I want, I can delete and take another selfie, or keeping it, I can still take another selfie. That is all possible. But the problem with this is, assume I took 100 selfies. I'm so much satisfied with the selfies I've taken. Okay. But your mobile battery dies. Just assume I had taken good selfies. I'm so much happy with my pictures. But my mobile switched off. Okay, my mobile turned off. Now I will put it back to the charge. I will open my mobile back. Do you think the photos will still be there in the memory if I have SRAM or DRAM? Any of it, SRAM or DRAM? Once the power is taken out, so there is no way the data is being retained. So doesn't matter how good your pictures are, so it is definitely getting deleted. So don't you think both RAM and ROM has their own problems which are not fulfilling our needs? Yes. So that is when we have something called as another category, which is hybrid memory. Okay, there's one more category called the hybrid memory. Now in the hybrid memory, we have two types. One is double EPROM. Okay, double EPROM is a type of hybrid memory, and second one is a flash memory. Okay, so these are the two types of hybrid memory. Now, if you take double EPROM, it's an electrically erasable programmable read-only memory. Okay, so one more here, E stands for electrically erasable programmable read-only memory. So that is double EPROM. Now, the advantage of double EPROM is you can have the memory taken, you can have the data returned. If you want, you can erase the data for any number of times electrically, and you can have the data re-returned for any number of times. You can erase the data for any number of times. You can rewrite the data for any number of times. That is electrically erasable programmable read-only memory. But the problem with the double EPROM, it has a very small disadvantage, which is its writing speed is very slow. Okay, the writing speed is very slow when it comes to the double EPROM. Okay, so understand that it has got too many advantages. So it is that whatever data you store is on a permanent basis. You can rewrite the data for any number of times, and you can electrically erase of programmable read-only memory. So that is also possible. Hard disk or SSD comes under hybrid memory. Yes, so that is a part of the hybrid memory, but we will not be using it in the embedded systems because generally hard disk and SSDs are bulky in nature, so they occupy more space comparatively to fit into an embedded system. So we generally don't make use of a hard disk or a SSD in any of an embedded systems design. So we do not discuss that here in the class. So we are discussing on the memory, uh, whichever can be used in designing an embedded system. So electrically erasable programmable read-only memory has an advantage that the data can be erased for any number of times and you can reprogram it. The problem with that is it has a very slow writing speed. In fact, it was taking around 5 milliseconds to have the data returned to one cell. So one cell, you can consider it as 1 byte. Okay. So to have 1 byte of data return, it is taking 5 milliseconds. If you think of writing just 10 bytes of data, how much time will it take to have 10 bytes of data return? How much time it will take? Yes, it is going to take 50 milliseconds. And think, just to write 10 bytes of data, it is taking 50 milliseconds. And 50 milliseconds, trust me, is a huge time when it comes to the embedded systems design. So using 50 milliseconds just to have 10 bytes of data return is really difficult. So it is having very low writing speed. Okay. So what we have made these days is some of the improvisations are being made on the EEPROM. Okay, these days, and it is taking 5 milliseconds to have one page of data return. Okay, a page can be, in fact, approximately 8 bytes or more. Okay, so remember, these days the improvisations are being made in such a way that 8 bytes of data is written in just 5 milliseconds. So improvisations are being made because people are using the EEPROM. Okay, so EEPROM is a hybrid memory. It is an electrically erasable programmable read-only memory. It has got good advantage that the data can be erased, rewritten. The disadvantage is its writing speed, which is very low. Okay, so 5 milliseconds was the time taken to have the data returned to one cell, which is of maybe 1 byte. So to have multiple bytes of data return, it was consuming more time. So now the advancements are being made in such a way that one page of data is returned in just 5 milliseconds. So EEPROM is a type of the hybrid memory. Understood? CDs and pen drives are EEPROM. Pen drives, I can say, CDs, you will get rewritable CDs, you will get the ones which are not rewritable. So the ones which are rewritable, you can say it as EEPROM, which are non-rewritable, which you can write it for only once. You can put it under PROM or under MASTROM. Okay. So EEPROM is one of the type of the hybrid memory. The next we have got is flash memory, which is further divided into NOR flash and NAND flash. So one is NOR flash, the other one is NAND flash. Okay, and I think it's time now to stop. So this we will discuss in tomorrow's class. Okay. So we started with embedded systems. We looked into the definition. We tried designing an embedded system, but we did not consider it to be an embedded system. Then we saw examples. Then we spoke about the categories of embedded system. Then we started with components. So we looked into SOC and then the memory. We are still left with flash memory. So tomorrow we will continue with this components of embedded system, and then we will continue with the introduction of embedded systems. The rest of the questions here we will look in tomorrow's class. Hope the class has all been clear. Have you got any doubts? You please make sure your doubts are being clarified if you have got any. Okay. So the Moodle is not being assigned to me yet. So I will not be able to take the attendance today. So your attendance will be marked from tomorrow. And today's attendance, I will be marking, looking at the attendees list. Okay. So, considering the attendees list, I will have the attendance marked today, and you can quit the session for today. Thanks for attending. We'll continue tomorrow. Okay. Ma'am, how much time takes for this module? I said it is around 30 plus working classes. When will be the lab starting? So for the next 3 days, you don't have any lab. So once we start with the peripherals, you will be given with an installation session, and then the lab starts after that. So for the first 3 days now, you don't have any lab. Can we store any data in the RAM? Obviously, yes. Okay. All right. So thanks for attending the session. You can quit for today, and your attendance will be marked from the attendees list. Thank you all.